test tomorrow. I'm recording this on Wednesday, so it should be up Thursday morning for you guys. I'll let you know that in class. This is going to be in 2 parts because I have to record it in 2 parts because I'm trying to get a couple questions in here before my AP class starts 6B. So let's go ahead and get started. So problem 1 on your review. I know it's kind of hard to see here. Let's make this a little bit bigger and then we'll move it. Alright, so at what part on the graph above is the original object moving the most slowly? Here's the thing you need to keep in mind for all 4 of these parts. If we are looking at the speed of an object and we have a position versus time graph, you have to look at the slope. So for part A, at what points on the graph above is the object moving most slowly? The question you have to ask yourself is at what points on the graph is the object have the smallest slope, the flattest slope? And that's obviously going to be B here and F here. No, in fact, not only are they moving the most slowly, but because the slope is horizontal, it's in fact going to be 0. For part B, we'll use green. Over what intervals on the graph above is the object speeding up? So keep in mind, if you're speeding up, your slope is going to get steeper. So it should go from flat to steeper. So what you'll notice here, if you look, okay, around, no, this is just not going to work for that. Let's see, do I have a pointer or anything? What's this do? No, that's not what I want. Whatever. All right. So if you'll notice, from A to B, our slope is getting flatter. But here, from B to C, our slope is getting steeper. In fact, it gets steeper all the way until DE. So the correct answer there is going to be B through D, at least for that interval. Now, we also see how from D to F we're getting flatter, but also from F to G we're also speeding up. So that's also going to be F through G. Now this is the answer to part B. There you go. All right. Now for part C, over what intervals are we? Here, I'll do this here. Answer in colors, I like it. All right. Over what intervals on the graph above is the object slowing down? So this is going to be the reverse case. Instead of our slope getting steeper, our slope needs to get flatter. So what we're looking at here is going to be from the start to B. Notice how that flattens out. And then from D to F, pretty much whatever we haven't colored in on the graph. Okay? Because those are the 2 areas where our slope is going from steep to flat. Last, I'm running out of colors. Go red. At what point on the graph above is the object changing direction? So we'll keep in mind, the direction you're moving is indicated by, hold on. Okay. Sorry, I was going to explain something completely different. That would be absolutely wrong. Okay. When are we changing directions? Well, remember, we're going in a positive direction if your position is increasing. That's positive. If you're going down, your velocity is negative. So, at what point are we changing direction? Well, we're going to be changing direction right here at B because we were moving away. Now we're coming back towards, and we're going to change direction again down here at point F. Okay? So, there we have question number 1. For question number 2, so we've got Bruce Tabuski and Job at the Pizza Parlor. All right, so in here we've got a word problem. Now remember, your first step for any word problem is to write down your variables. What do you know? So, our 5 variables are V naught, V final, acceleration, delta x, and t. There we go. All right. So the thing to ask yourself is, are we accelerating or is this constant velocity? So we skim through and it says Myrtle started the pepperoni at rest and accelerated it. Okay, so right there is our key. So if we're accelerating, that means we've got to use one of those 4 equations. Remember, you will be given those on the test. So let's start plugging in what we know. Myrtle started the pepperoni at rest. At rest means it was started with a velocity of 0. It accelerated through a distance of 2.5 meters. Hey, guess what? That's displacement. The final speed of the pepperoni was 10 meters per second. No more clear way of writing that. V final is 10 meters per second. What was the acceleration of the pepperoni? So it asks us here for A. It doesn't ask us for T. It doesn't give us T. We don't give a crap. So what we're going to do is pick the one equation we have that does not involve time, which is V final squared equals V naught squared plus 2A delta x. We know what V final is. V naught is 0. We're looking for acceleration, and delta x is 10. Okay? So what we're going to do here is, well, first of all, 10 squared is going to be 100. And then we've got 2 times 10, which is going to be 20, right? Don't know why I'm asking a recording, but we're just going to go with it. Okay? So what we're going to do is go ahead and divide that 20 over, get it out of the way. And when you take 100 divided by 20, that's going to give you an acceleration of, wow, I can't believe I blanked on that for a second, 5 meters per second squared. Okay? So again, the key points here, list out your variables, pick the one variable you don't care about at that particular moment in time, find the equation that doesn't have that variable. You've only got 4 options, so it's not too bad. All right, should have time for number 3, hopefully. Actually, you know what, I've only got about a minute, so we're just going to go ahead and finish it up here. So there will be a part 2 of this video. It should be linked. If not, go back.